So what we know here for sure is X and Y are related linearly. V and W are related, but kind of parabolically, all right, non-linearly, but they're related. And the others are not related. They are just random. Okay. So now we know this. We saw how they are being generated. Let's imagine that DF2, the final DF2, is being saved in an Excel. Okay, we learned how to do that. And now it is being passed to us. Somebody created this DF2, save it in a file, passed to us, and we read it back and we were told, analyze this, tell me if there is anything interesting. That means, anything correlated or showing some pattern. Okay, all right. So there are 4 lines. Now, remember, again, this is just for demonstration with this limited screen real estate and limited video time. This can be 4,000 columns with extensive data gathering. Okay, so how are we supposed to do this? If your idea immediately is, let me plot charts and then eyeball it, that's completely off course, right? Not the right way to do it. First thing first, always let pair plot do the job. So I hope you keep this in mind. When we are faced with this exploratory kind of nature, the first thing, we don't know what to do, right? Maybe there is relationship, maybe not. If there is relationship, which one and which one, or which not? Just do a SNS dot pair plot that data frame. Okay, why do we do that? Because the outcome is this. The outcome is V, for all the diagonal entries, the pair plot will show distribution of that variable. So for example, V paired with V, nothing interesting. So pair plot will plot the distribution of V. In other words, the histogram of V. Now, maybe the scale, the x-axis is not there, but it's not important. What we are going after is the shape, any recognizable shape, or any interesting features. Okay, so this is basically a bell shape telling us that V is most likely a normally distributed set of data. Most likely because ultimately we need to use statistical analysis to confirm it, but then visual comparison is very important as a start. Then we know that W exhibits certain kind of distribution, although we are not sure it is normal or not. Then we have X, which, interesting, right? It doesn't look normal, but it does seem Poisson. Maybe you don't agree because you say I already peeped at the data source, right? But yeah, it might seem Poisson, but definitely I hope you agree that it's interesting. It's very kind of regularly spaced, and it is going first up, then down, and then very regularly downwards, exponentially decaying to nothing. So that is very, very strong sense of being Poisson related. But we may not directly understand this upfront. We just find that it's interesting, all right? And finally, this is also interesting. This could be some sort of a chi-square plot or normal distribution, which looks alike, a lumpy kind of distribution. So we're not sure whether it's normal or not, but it certainly looks interesting. All right. Then what is much more importantly is the off-diagonal plots, where we will have V scatter plot with W, V scatter plot with X, this one, and V scatter plot with Y. Okay, here, be careful between the concepts of correlation and scatter plot. Like I said earlier on, correlation shows strong extreme values if it is strongly linearly, line-wise linearly. Uh, the pattern shows up much like a line, like such as in this case, right? So V and W, this is pretty much a line, although there's curving somewhat. It should kind of, or at least it is quite well approximated by a line. Then it will show up like this. Okay, and also we can look at this. This is much more linear than this curve, and therefore we would suspect x and y to be very strongly linearly correlated. Yeah, because if I draw a line, you will agree that yes, it is a line. X and y are very reliably connected. If X increases by this amount, Y will increase by that amount, almost for sure. That is what we are saying. Whereas this, first of all, it is a negative gradient, but if I draw a line, let me actually draw a line. If I draw a line like this, some of you might agree, some of you might disagree. It's a good line. If I draw a line like this, sorry, um, erase. Okay. And if I were to draw a line like, I hope I draw it right, this. Now, maybe more of you agree that this is a better line, but some of you might disagree as well, right? So it's not really fitting when we try to use a line to summarize this V versus W. So what can we do? At least now, so if you use correlation, you cannot see this very nicely. The correlation might show as 0.3, 0.4, or maybe even 0.1. And we would have lost a lot of interesting stories between V and W. But with scatter plot, our eyes can detect that they are very strongly connected. When V changes, W will change, almost for sure. However, the change is not necessarily the same proportion all the time, right? So that's why we see a curve. Again, a pair plot tells everything immediately. And these diagrams, with experience, you will see that V and Y exhibit no relationship. It's pretty much random. So it's like if you throw a dart, more or less is all over the place. No, okay, not for you, maybe for me. So it's all over the place because it's just random aiming, right? So it will end up like that. And that is true for the other chart, W versus Y. And because it's symmetrical across the diagonal, it's sort of like a mirror image between upper and lower triangles. So we just need to analyze one side of the triangle. Okay. All right. So we can definitely run correlations. All right. We run correlations with the same, calculation statements. Just dot core, just do a hard dot core dot replace one with zero, and then do a heat map choosing Coolwall. And immediately we see V and W being shown up as negative gradient, right? Very, very negatively linearly correlated. So in other words, the dot core showed up the connection, the very strong linear approximation to V and W, even though we know they are not exactly linear. But parabola, right? There's some part of it that is kind of like if you don't go for too large a range, you wouldn't see the U-turn there, and so you will find that this segment seems to be well approximated by a line, and this is the reason. And X and Y, we know that from birth, X and Y were supposed to be linearly correlated and positively, so definitely this is very strong. In fact, it's stronger than we can't tell the color or directly, but we know that this ought to be stronger than the negative correlation shown by the V and W relationship. All right, lastly, just a reminder, again, since Seaborn is so powerful, do we always try to show pair plot? And the answer is actually no. Pair plot is not something that we show to our customer, our users, our audience, unless you're doing some sort of a scientific presentation or internal communication with your colleagues. But by and large, it's for us to for us, that means if I am trying to analyze this data frame, I would want the Seaborn's pair plot to help me. So I'm the user and reader and beneficiary of the pair plot chart. Okay, so let's talk about data analytics, visualization as a role, as a tool in data analytics. If you want to investigate, explore, or illustrate relationships, patterns shown by two quantities, definitely scatter plot. Okay, so because they line up or they don't. To investigate, explore, illustrate frequencies, right? And across categorical numerical measurements, use heat map. The hotter it is, the more intense the frequency, right? Something like that. Then we need to explore the correlation. So definitely use .core. It's so easy to compute correlation of all possible pair combinations of the columns. So we don't have to think about the algorithm to generate combinations. Just run .core will do. So that's very good, right? So then we do a heat map on the .core of the data. We can also use bubble plot to investigate three-dimensional, four-dimensional pattern, possibly, or substructures occurring within a higher level. For example, we were earlier on talking about scatter plot, right? Scatter plot of number of years of education versus income. So we might, well, we can study that, or we might be asking, how about, how about um, gender and income in education, right? So we might say, all right, um, higher education and male, right? Male higher education, female higher education, income level. What's the difference? So we might not see a line anymore because perhaps in certain countries, in certain culture or certain developmental phase of countries, uh, the years of education on average might be different. Or we might even throw in another important demographic variable, age. Certain countries allow higher education to be done later, not necessarily at a young age, right? So we can have four variables: education, income, gender, and age group. And that will be interesting to look at if we can. And the answer is yes, you can. So use bubble plot to include these four uh, suspiciously connected demographic variables, and yet we are not sure if there's connection, isn't it? So scatter plot them. Now, again, let me remind you, scatter plots can show all kinds of relationship, curve relationships, line relationships, but correlation can only show a linear relationship. It's a little bit like a Geiger counter for radioactivity, right? So a correlation calculation map basically is like we know a lot of radiation, no radiation, right? A strong linear correlation, no linear correlation. It cannot detect other kind of relationships, okay? But scatter plot we can detect, provided we partner our eyes. And that's why a properly drawn scatter plot is very important. And finally, very, very important word, but putting it at the last just means that I want to remind you afresh again that when you are given a data set, and by that I mean download an Excel file from some website, past a USB thumb drive containing certain files from headquarters, from your colleague, from your branch, from all over the place. You have this new set of data. You have no idea what you're looking at. Yeah. First thing that you should do, just run a pair plot. All right, just run a pair plot. Let the pair plot visually guide us in, zoom in on this. Hey, this looks interesting, right? Then we can examine further. Yeah, so this is exactly what I would do if I were you. Okay, so that wraps up our classroom study of the software and usage and understanding aspects of data visualization using Seaborn. And of course, the next video segment, the exciting part on actually driving Python to generate these graphs. See you in the next video.